So we have faculties from UC Berkeley, UC San Diego, down in UCLA. How about having a UC AI Summit? So I'm a associate professor at the UCLA, and I also work with Coco Robotics. Today, I would like to share with you how we think about scale up the sidewalk autonomy with world models. Right, so probably most of the people here are familiar with autonomous driving. So we have a previous speaker talk about their amazing research on the road autonomy, right? So we have this full-size vehicles running around the cities. But for our urban environment, there is another kind of autonomy. Here I call it the sidewalk autonomy. So here is a sidewalk robot is doing the food delivery task. So this is a robot from Coco Robotics. So Coco Robotics is a startup running this kind of last mile food delivery service. So we have hundreds of robots running around to fulfill this task. You can see compared to the roadside autonomy, this sidewalk robot have to handle a lot of challenging settings. Let me show you some of the videos like from the first person view of the robot. Now you can see here this sidewalk robots have to really carefully navigate on the sidewalk and avoid the collisions of obstacles. Also the robot has to handle all the weather condition and the lighting condition. Also on the sidewalk, originally designed for people, right? So the robot have to properly and socially compliant interact with dynamic agents such as pedestrians and animals like dogs, right? So here's another videos I like a lot. Now you can see here is a dog just lying on the sidewalk. Then the robot have to navigate very carefully to avoid stepping on the tail of the dog and achieving the navigation task, right? So from those videos, you can see the sidewalk conditions are very challenging. Also, the robots work in compute and battery-constrained environment, right? So we only allowed to use single RGB cameras to do the navigation. So in recent years, people developed a lot of AI models for the sidewalk navigations. So basically, they are imitation learnings to learn from the human demonstrations. So many models have been developed. My lab has contributed some of the models. Other labs also propose some great models. So those models are trained on the video demonstrations that can generalize very well across different conditions. But we have a challenge here, given so many different AI, like sidewalk foundation models. How can we benchmark those navigation models before the real-world deployment, right? So we are building up the benchmark. So here is a benchmark we built called the Sidewalk Bench. So we want to evaluate the navigation policies or models in simulations. So here we utilize NVIDIA Omniverse and Isaac Sim to build this simulation environment. So we can evaluate different models and then compare their capabilities, how they interact with peoples, how they avoid collisions. But if you look closely, those graphical simulation built in this graphical engines still lack the visual realism, right? So compared to the real-world deployment, there is still a scene-to-real gap. So we want to address this scene-to-real gap to more fairly evaluate the model capabilities. So our solution here is creating the world simulations from the real-world videos. So we want to use real-world videos as a source code to build up this evaluation benchmark. So here is a work we developed last year, published at the CVPR. It's called V2Sing. So we can take videos like walking on the sidewalk. Then we can build Gaussian splat reconstructions from the videos and turn this splat into this physical engines. Then we can have this kind of data-driven simulations. Then we can train and also evaluate the sidewalk robots in this kind of data-driven simulation. So here, this demo video showing you the training process. So we can train the agent with reinforcement learning. Then after the trainings, then the model can zero-shot transfer to real world because there is no a visual gap between the training environment and the deployment. So based on this Gaussian standard environment, how we can evaluate all those different sidewalk navigation policies and see how this model handle different cases. But still, there is a limitation for this kind of video reconstruction, because we can only reconstruct one environment from one videos, right? So ideally, we want to create several variations from the same videos. So that's a motivation behind a recent work we called Urbanverse. So we want to create multiple digital cousins from the single video, right? So here the digital twins means one video corresponds to one simulation environment. The digital cousins means we can have different variations. So here we utilize the computer vision techniques to extract the scene graph from the input videos. Then we can plug in different object instances. Then we can create a different variation of the environment. Then each environment can be used for training and evaluation. So this Urbanverse we release to the public, and we also release a large-scale 3D assets, which contains 100,000 assets with the correct skills. So for this kind of environment, then we can use the environment for evaluation. We also developed the pipelines to do the post-trainings with the simulation. So basically, we train the model first on videos through imitation learning. Then we can put the models inside the simulated environments and further do post-training to improve their interactivity and the counterfactual reasoning capabilities. So given all this progress, we have this recent work we call the Flow Pilot that can implement this kind of real-world sidewalk navigations from a single RGB cameras. So here, this robot only have one RGB camera. Then the model will output the waypoints. Then the controller will execute the next point. Now you can see here, this robot can handle this challenging sidewalk navigations, like know how to avoid the collision with obstacles, and also how to interact with pedestrians properly. Another very exciting direction is this cross-embodiment transfer or deployment. Given this sidewalk navigation foundation model, we have research that to transfer this model across different robot embodiments without fine tuning. So this demo video is showing you that this model can work really well for this lagged robots. We also have many ongoing research that trying to transfer the model to many other sidewalk robots, like the wheel-lagged robots, as well as this electronic wheelchairs, right? So in the future, not only we can autonomously deliver the food, we can also autonomously deliver the people on the sidewalk. So we release benchmark and the code at our web page, so you can access code and papers from this barcode. So here I would like to thank all my students and the collaborators. Thank you.